Hi, I'm Jeff, and this is Lithic Metals. Welcome to the lab. Today I'm going to do a kind of an unusual experiment here. This is a batch of scrap silver. A couple things I'm not even 100% sure what they are. Some things are marked sterling, but they're clearly not. Whenever you get a big batch of silver in, you come across so many things that are marked sterling, and they are clearly not. Anything from copper to lead to you name it, steel. Well, a lot of times I'll pluck those things out, set them aside, or if, like this little necklace here, it's got a ton of these little stones in it. Usually you take the stones out. Well, that's just, this would be a ton of work for what the precious metal value is. So what I'm going to do here is I didn't remove stones. There's catches for necklaces in there, a bunch of just odds and ends that kind of just been sitting in a little bucket here for quite a while. So what I'm going to do is digest this material in some nitric acid, dilute nitric, and I'm going to drop the silver out of it, and we'll see. There is some gold-plated material. Some of that might float up and form part of a residue or sink to the bottom. A lot of time with the gold-plated stuff, it's just very little value. There might be one or two little pieces that might surprise you, but for the most part, I'm probably going to end up filtering that material out and addressing it later. But for right now, what I'm going to do here is I'm going to incinerate this stuff, make sure that all the dirt and oils and whatever, maybe plastics, if there are any, I'll be able to spot. Lead often shows up in this part of the process. You'll just see it melt instantly and start to form a puddle, so you can pluck that out of there. There's going to be some steel catches and whatnot that I normally would take out, but this time I'm just this is going to be an experimental batch. In the end, we'll end up with pure silver, but there might be a few complications along the way. But for right now, let's turn on our exhaust fan and incinerate this stuff here. Incinerate, I don't mean vaporize or anything like that. I'm just heating it up enough to get it to be red hot. Start anything on fire that shouldn't be there. And of course, I always have a few silver screws laying around, so I'm going to throw that in there for good measure. You always wear eye protection. I have a face shield on. You never know what you're going to come across in this stuff. Alright, now that's complete. Let's move over to the fume hood. We're all set up in the booth here. This is going to be pretty simple. We have 400 mLs of distilled water. I have 100 mLs of nitric acid in waiting. I think our next step here, we can just start putting our silver in here. You know, a lot of, normally, after incinerating, I would go and take this and rinse it all off, get any ashes and any residues off. But this one is just going to be a hot and sloppy experiment. I'm going to make it as simple as possible. I just want to see if any complications arise, and if they do, we'll just see how we fix it. I am going to be a little bit more cautious towards the end here. We don't need to purposely include ash. Yeah, right here. Water. Looking at that filthy mess, I think I might have changed my mind. After putting that material in the water, I had second thoughts about not rinsing it off first. There's a good reminder of why exactly I do that. Cloudy, there's floating residue, but whatever, let's stick with the game plan. We're just gonna go with it, and if troubles come up, we'll address it as it goes. But normally, I definitely, after you incinerate, I would recommend rinsing it off real well, distilled water. Get it cleaned up again. It doesn't have to be perfect, but the more you do, the less you're going to have to worry about any sort of slime that you're not wanting to deal with. But anyway, let's get our experiment going here. I'm going to add... I just turned the heat on, so it's rather cool yet. It's going to start to warm up over the next few minutes here. Put on approximately 20 mLs here of nitric. You can see immediately we have a reaction going on. Cold water, cold acid, room temperature. Right away it goes right to work. So before we go bananas, we don't want it to overreact. If there's something in there we didn't expect, we don't want it to be some sort of catastrophe and blow up all over. Well, not blow up, but literally foam over or anything like that. So we're just going to take it slow. We'll give this a few minutes to warm up, and once it gets up to temperature, we'll add more nitric acid. Alright, I'm going to close the fume hood, turn the fan on high, and we can observe. In case I wasn't clear before, I kind of rushed into this. What we have here is a bunch of miscellaneous scrap silver. Pieces that where the stones weren't worth removing. I have a bunch of clasps in there that normally I would take the springs out and everything. Normally I would just resell those clasps, but if I were to digest them, I would break them apart, take the steel springs out. I don't want to have to deal with that normally. But with silver, it's, gosh, there's probably 100 clasps in there. Maybe closer to 200 clasps probably. And I wasn't going to take the time to bust all those little springs out. If it was gold, that'd be a different story, but this is silver, so I'm just going to let this dissolve, and when we're done, when all the silver's digested, we might leave a little bit of scrap here and there. If something is really lingering, hanging in there, we might just leave it and deal with it on a different round. But what we will be left with is a bunch of cheap stones, a bunch of little tiny steel springs, maybe a plastic bit or two. We'll see. We'll see at the end. We'll check out the filter and see what we get. And I'm also predicting that we'll have a little bit of gold flake, some gold powdery, not powdery, but real thin plating residue as well. So we'll filter all that out, and who knows, if we see enough of the shiny little stuff, maybe we'll address that as well before we put the filter in the basket. Alright, we'll give this a few more minutes, let it come up to temperature, and we'll be adding more nitric. Already at 145 degrees, so we're getting pretty close to the temperature that I want it to be at. I want it right about at 165 degrees Fahrenheit. Alright, it's been about 10 minutes since I shut the camera down, and of course, as soon as I turned it off, I turned around, went to the laptop. I turned back around to look at it, and our solution went black. And of course, the camera wasn't running. It would have been great to see that transition. But here is what we are now. It's lightened up. It really went jet black. It was like, whoa, it's something new. I haven't seen it go like that ever. Ever. But yeah, so now we have a brown, dirty solution. Yeah, it might change. As you can see, we don't have any more red fumes. Our nitric acid is pretty much used up. There's not much of a reaction. The bubbling that we have going right now is just the heated solution. I think at this point, since it's so hot, I'm not just going to pour another 25 mLs in quite yet. You know, it might still come to that, but right now I'm just going to use the pipette and put in a few mLs at a time. See if we can clean this solution up, or maybe it'll even get worse as we go. We'll just have to kind of see on this one. Alright, well, let's get to it. Add a few ml at a time and see what happens. Took the brown down. You see the fumes go back up the pipette? Let that work for a minute. Well, we used up our initial 100 mLs of nitric acid, and we are left with a bubbling slurry about as nasty as I've seen. My thoughts were I was just gonna keep going and going, but everything in me says I have to isolate this stuff away from the rest of our batch. So I'm gonna decant this into another beaker, and we'll start fresh with fresh distilled water and nitric acid, and we might get the same results. It might turn just as nasty as it is now. However, I think it'll do us good just to separate this and re-energize our solution with some fresh ingredients. All right, let's get to it. What I'm going to do is I'm just going to let this get up to temperature, and I'm going to pour this off again. We'll let that get up to temperature and check back with it in a little bit. Alright, well, our solution has heated up. I'm going to pour it off. You know, we could probably do this same procedure 6 more times and we're still going to be coming up with this irony brown looking mix here. So I'm just going to pour this bit off, refresh the water, and we can start fresh with some nitric. Alright, I got another 100 mLs of nitric acid set up. I'm not going to continue to keep pouring this off. We're just going to deal with the mess we made here. It's like congealed together. That was essentially 25 ml. Cover that up, let it get up to temperature. Well, it looks like our reaction is starting to stall. I'm going to check the temperature, but I think we're at least to probably a 140 or above. I'm also going to dilute by half our nitric acid that's in our beaker. And that way I don't have to use the pipette. I can just pour little bits at a time. I still have to be careful. 2 reasons. One, when I do that, I don't have to worry that I'm losing too much water, because I want to have basically a 50-50 ratio in our main beaker
for our dilute nitric to work, and I have plenty of distilled water in the beaker already, but that is one reason that I would do that. Another reason is it's cold, and when I pour it in, it actually lowers the temperature of our solution by a couple degrees, and it just it sets the reaction back a little bit and lets it build up a little more slowly. Still have to be careful because it can flash back on you if you pour in too much. All right, let's add a little more. Alright, we went through our second round of nitric acid. The reaction has stalled. The bubbling that we see there is just from the heat. So I am going to turn that down. Let that cool down for just a second. And I'm going to switch it up. We're going to have more waste with this experiment than I normally would. 'Cause normally I would push this solution a little more, but I just want to keep decantering it off here a little bit. Freshen it up a little. Eventually maybe we'll come to something that a color that we're supposed to have. But I think I'm going to start to empty this waste into a bigger beaker. Not have to worry about flip-flopping it around too much. All right. I think at this point it would be wise just to switch this out as well. We went from a 1 liter beaker vessel to that's a 2 liter beaker. So we won't have to worry as much about any overflow, flare-ups, anything like that. Still have to be aware, have to be alert for it. But won't be as big of a concern. I diluted 100 mLs of nitric in distilled water. I'll be adding that incrementally. So the heat is turned on. The water's fresh. Nitric acid is fresh. Surely can't tell by looking at it. However, it is what it is. So let's let it do its thing, and we'll let it warm up and keep an eye on it. Tend to it in a little bit. The solution color now, you'll notice, is really dark green, cloudy. That's a bit more typical about how your solution is going to look doing sterling silver. In my experience, whenever I do big batches, I definitely have a bunch of crazy stuff. You know, you try to limit the steel, the springs, stones, because some stones, you know, they call them paste or whatever. You don't know what they're made out of, you know, especially in silver stuff. It could be plastic. I've removed stones and found folded up newspaper behind it, you know, where they packed it in there to keep it snug. And yeah, you never know what you're gonna find. So it isn't ever always crystal clear. You'd think, ideally, you'd love to think that it's this deep blue with the copper and nice and clear, but no, it stays this grungy, dark green color. And what we have now is a lot better than what we started with. That first batch really came. What I'm thinking that is some sort of steel, iron that was easily corroded away, and I was dosing the acid. That doesn't sound right. I was using small amounts of nitric acid, and I think at times the pH went a little too high, and I think it's like if it goes above 7, iron drops back out, and I believe that's what that brown mud that we had, that sludge, I think iron dropped back out of solution when the pH level rose too high. We'll deal with that, but I believe that's what was happening. I've been doing a little larger doses over here, and that's been keeping that brown away. I wonder as the reaction stalls out at the end if that iron would come back out again. But we'll see. We'll see. We're getting down there now. You can see some every once in a while, or you see on the surface the shells of those gold-plated necklaces that were in there. Now they're just floating on top. It's amazing how they hold their shape. I'll try to get a closer look here in a minute. Yeah, so we will tend to those too. We'll gather those and it is not a lot of gold. It looks like a heck of a lot more than it truly is. But we'll find out at the end what we have. Let's see if we can get a close-up here. Reaction has dwindled down to almost nothing here. I'm going to check the temperature. I'm also going to stir it around a little bit with the glass rod and kind of get a feel for how much is left. I do see some pieces. Those could be pieces that are not going to dissolve. You know, I got to take a closer look. You know, if they're certain stainless or something, they might not get eaten up. So we'll check the temperature, stir it up, see if we need to add more nitric, and if we do, we're gonna do it slowly. Actually a little bit more in there than I was expecting. So I am going to continue with the nitric. Got a fresh 100 mLs here, not diluted. It's right about 20 ml. Give that a few minutes to work. Well, we've used up most of the free nitrates that are in solution. I'm taking a closer look here, and yeah, the bubbling action that you can see at the surface is just caused by heat at this point. The pieces of silver that I can see against the glass are zero reaction. So I am going to turn off the heat, pour this material off. I want to be able to see. We don't have a lot of silver left in our beaker here, but I want to be able to see it a little bit better if possible. So I think I'm going to pour this off, maybe even depending on how much material is left in there, I might transfer it to a smaller vessel. So let's get cracking. We have a bit more material than I thought we were going to have. But upon closer examination, there is a lot of junk in there. But we will transfer that to another beaker here. Let's shoot. Alright, we'll close that up. Let it get up to temperature. And work down the rest of that silver. All right, it's time to add a little more acid here. Our vessel looks like the reaction's pretty vigorous, but temperature's just turned up a little too high. So I'm going to cool that down a little bit, check the temperature, and add a little bit more nitric, dissolve the rest of this material. That go for a bit longer. And, add more if we need to.
there's no fumes. The air above our solution is pretty clear. Fluid's hot. You see the color. That would be a more typical color on a batch of silver that you're doing, or sterling silver. If you take in the sterling silver, you remove springs and clasps and whatever steel you could find, test all your pieces, verify that they're sterling. Your solution's going to look a lot like that. You'll have pieces that trick you. They'll have lead in the center, or there's zinc, all kinds of, you name it. They'll mix something in that silver just to make it, I guess, to make their alloy, but typically I think it's just to make a fake piece. A lot of these pieces, if there's, well, I was going to say, if they're stamped China, you got to be leery about it, but I don't want to blame, everything on China. It is a sign. If it stamps China, if it's silver from China, you might want to take a second look at it. On the button. Okay, I turned the heat off. I'm not going to add any more nitric acid to it. The pieces that I see are tiny, and I do see just a slight reaction against them. So I'm going to let it, as it cools, I'm just going to let it sit. It's going to stay hot for quite a while, so we'll let any remaining free nitrates get burned up on the remaining material that's in it. I'd much rather just stop ahead of it, so instead of shooting too far. I'm going to give it a half hour to an hour to cool, and then pour it off into our large beaker. At that point, I think I'm going to let it sit overnight, and decant it and filter it in the morning. See what kind of sludge we got at the bottom. Alright, this cooled down enough to pour off. I thought for a second about keeping that last remaining bits out of there and just dealing with it separately, but there are actually particles of gold all laced in there, so it's still going to have to go through the same process that I was going to do with the rest of the sludge at the bottom anyway. So I decided at the last second there that I'm just going to
stick with my original plan, dump it in there, and we'll let that all settle to the bottom. It's been a long day, so I'm gonna call it quits for tonight, and maybe we'll continue the next part of the video as part 2.